All right, let's dive into one of the most fascinating, mind-bending ideas ever, time travel. Now, for more than 100 years, it's been the stuff of science fiction, right? But what if I told you that real, actual physics has a ton to say about it? Well, today, we're going to separate the science from the fiction. So that's the big question, isn't it? Is this all just make-believe? Or are there actual, legitimate pathways through time that science can back up? That's what we're here to do. Peel back all those layers of fiction and see what physics says is really possible. You know, to really get a grip on the science, we've got to go back to where the whole idea started for most people. And you might be surprised that this whole scientific quest really kicked off because of a single game-changing book. Yeah, way back in 1895, H.G. Wells published The Time Machine. And it wasn't just a popular story, it was a spark that lit a fire in our collective imagination. It got so popular, in fact, that it basically forced scientists to stop laughing off the idea and to start asking a very serious question. Wait a minute, could this actually work? Okay, but before we can even dream of building a time machine, we have to ask a more basic question. What even is time? And for a very long time, science had one answer, until a certain patent clerk completely turned our understanding of the universe upside down. What you're looking at here is one of the biggest shifts in the history of science. For centuries, everybody lived by Newton's clock. Time was an arrow. It shot forward, never wavering, the same for everyone. But then came Einstein, and he just shattered that idea. He said, no, time isn't an arrow. It's a river that can flow faster or slower. And that one idea, it cracked the whole concept of time travel wide open. And that's the million-dollar question, right? If time is this flexible, flowing river, why does it feel like a one-way street to us? How come we can remember the past, but we can't remember the future? Well, the answer is baked into one of the most fundamental laws of the entire universe. And that answer has a name: entropy. It sounds complicated, but the idea is actually pretty simple. It's the universe's hard and fast rule that things always move from a state of order to a state of disorder, or chaos. And that constant, unstoppable march toward chaos, that's what gives time its forward direction. Think about it this way. You've got a glass sitting on a table. That's a state of order. You knock it off, and it shatters into a million pieces on the floor. That's disorder. Easy, right? But have you ever seen those million pieces just spontaneously leap off the floor and reassemble back into a perfect glass? No way. Of course not. That irreversible slide into messiness is what our brains perceive as the past becoming the future. It's time's arrow, and it's drawn by chaos itself. Okay, so if we accept that time is a river, Einstein's incredible theories actually give us 3 potential ways we could theoretically navigate it. And these aren't just wild guesses. They're ideas grounded in the real, hard physics of space-time. Let's start with method number 1. This one is all about speed. I'm talking about going really, really fast. This idea comes straight from Einstein's theory of special relativity, and it's probably the most solid, scientifically proven method we have. So the mind-blowing idea here is that space and time are 2 sides of the same coin. They're woven together. And as you start moving faster and faster through space, time itself actually has to slow down for you, compared to someone who's just standing still. It's like a cosmic trade-off. You trade speed through time for speed through space. And the results of this are just staggering. Let's say you could hop in a spaceship and travel at almost the speed of light. For you, on that ship, only 1 year would pass. But when you came back to Earth, you'd find that 572 years had gone by. You would have effectively taken a one-way trip into our planet's distant future. All right, so that was speed. The second method doesn't rely on going fast at all. Instead, it relies on the most powerful force in the entire universe: gravity. You see, Einstein's next big idea was that massive objects, like planets and stars, don't just pull on things. They literally bend and warp the fabric of space-time around them. And in the places where gravity is strongest, that river of time we talked about slows down to a crawl. And, of course, the most extreme example of this is a black hole. The gravity there is so ridiculously intense that time gets stretched almost to a breaking point. If you've ever seen the movie Interstellar, this is exactly what they were talking about. Spending just a few hours near a black hole could mean that decades or even centuries pass for everyone else. Now, here's the thing about those first 2 methods. They're one-way tickets to the future. But what about the real holy grail of time travel? What about going to the past? Well, for that, we need to talk about our third, and by far most theoretical method. This is the idea of a wormhole. Basically, it's a hypothetical tunnel through space-time. Imagine taking a piece of paper, folding it in half, and poking a pencil straight through both sides. That's a shortcut. A wormhole would be like that, but for the universe, a bridge that could connect two very distant places, or even more amazing, two different moments in time. But, and this is a big but, here's the catch. While the math says they could exist, they're nowhere near practical. For one, if they exist at all, they're probably microscopic. They'd also be wildly unstable, popping into existence and vanishing in the blink of an eye. To actually hold one open long enough to travel through it, we would need something called exotic matter, a bizarre substance that has negative energy. The problem? We have no idea if it's even real. But okay, let's just pretend for a second. Let's say we figure it all out. We build a stable wormhole. We can travel into the past. This is the moment where physics kind of steps back and logic steps in. And this is where things get really, really weird. This leads us to the classic grandfather paradox, and it's the biggest headache for anyone who wants to travel back in time. So just imagine, you go back in time and you do something that prevents your parents from ever meeting each other. And you see the problem? This is where logic just ties itself into an impossible knot. Because if you were never born, then you couldn't have grown up to travel back in time. But if you never went back in time, then you were born, which means you could go back. It's a loop that cancels itself out. It makes no sense. So we end up here at this incredible crossroads. On one hand, the laws of physics, as we currently understand them, seem to leave the door for time travel at least a little bit open. But on the other hand, the laws of logic seem to want to slam that door shut. So what does that mean? Could it be that these paradoxes are the universe's way of protecting itself, a sign that maybe, just maybe, the past is something you can look at but can never ever touch? Now that is something to think about.